name is Dayang Nurfazliana. Today we want to present Chapter 2 Differentiation Stationary Points.
Hello, before we start our presentation, let me introduce myself and my team. My name is Nurul Syaifawani. My matrix number is 07DKA23F2001. And my team is Debra Lee Hui Lee 07DKA23F2015. Next, Amira. Matrix number 07DKA23F2047. And last, Dayang Nurfazliana. Matrix number 07DKA23F2006. In mathematics, differentiation is a fundamental operation that involves finding the rate at which a function changes with respect to one of its independent variables. It is a process of determining the derivative of a function, which represents the slope of the tangent line to the function graph at a given point. In this presentation, we will focusing find maximum, minimum, or inflection point and sketch the graph of the curve.
To solve the question from the previous slide, there are steps you need to do first. The first one is find dy over dx equals 0 in order to get the value of x. The second is subtract the value of x from 1 into equation y equal f in bracket x to find the value of y. The third is state your stationary point in coordinate x, y, and determine the nature of stationary point using d square y over dx square. The fourth is complete the table and sketch the graph. This is the first step you need to do to solve the question. The step 1 is find dy over dx. So y equal to x cubed minus 3x squared. So the dy over dx equals 6x squared minus 3x. So the dy over dx equals 0 factorized is 6x squared minus 6x equals 0. So for the x1 you will get 1 and x2 you will get 0. Step 2 is you need to find the y. So when x1 equal to 1, so y equal to x cubed minus 3x squared. So the x, you just change to the x1 value, which is 1, so you will get minus 1. For the x2, you just repeat the same step as you do for the x1, so you will get 0.
The third step is to determine the stationary points. So the first one is 1 to negative 1 and the second one is 0 to 0. The next step, which is the fourth one, is to determine the nature. So dy per dx is equals to 6x squared negative 6x, and we have to differentiate it again to get d squared y over dx squared, and then we get the answer of 12x minus 6. So after getting 12x minus 6, we have to substitute in the x value, which is 1 and 0. So when x is equals to 1, we can get the value is equals to 6, which is more than 0. So this gives us the minimum point. So when x is equals to 0, we can get the value is negative 6, which is less than 0. And that gives us the maximum. So for the fifth step is to sketch the graph. But before that, we have to make sure the value is correct. So we have x and y. Negative 1 and 1 from the x value came from the one that we factorized on the first step. So after that, after we found the value, we just substitute it in to the first equation, which is y equals to 2x cubed minus 3x squared.
The graph is plotted according to the calculation from the previous slide. In conclusion, differentiation is a crucial tool in calculus that enables us to determine the rate at which a function changes. The derivatives of a function provide us with valuable information about its behavior at any point in its domain. The derivative can tell us if the function is increasing or decreasing, whether it has any maximum or minimum, and much more.
Assalamualaikum. That concludes our presentation. We apologize for any mistakes in pronunciation or the material we cover. Thank you for your attention from us, Group 7. Me, Nurul Syaifawani. My matrix number is 07DKA23F2001. And my group member is Amira, matrix number 07DKA23F2047. Debra Li Hui, matrix number 07DKA23F2015. And last, Dayang Nur Fazliana, matrix number 07DKA23F2006. Thank you.